Yes, this already. Um,
I think it's probably fine. We can leave it out. We have the recording too if anybody needs it.
Okay, great. Well, thank you all for joining. I see mostly familiar faces, but for anyone new, my name is Lisa Dinan, a program manager with the Great Lakes Business Network and a Great Lakes Water Program specialist with the National Wildlife Federation. And we're so glad you're here to learn today more about microplastics and some of the threats that they pose to the Great Lakes. So this expert panel should be really informative, and we hope that you'll learn something new and maybe refresh on something that you've learned before. But just to provide some context, this is part of our initiative to make GLBN engagement with microplastics more thoughtful, and to build out a more formal campaign to engage businesses in this Great Lakes issue. So we've been working with this team of student researchers from C's master's program at the School for Environment and Sustainability for about a year now, and we'll continue with this partnership through April or May of this year when they wrap up their capstone project. But the team of students have really done a lot of work to pull together this webinar in response to some of the feedback that they learned from our business members when conducting the sort of landscape interviews across the network to learn more about what businesses are doing to address plastics and what they would like to be doing. So I will let students take it from here, and I'm really excited to learn more from our expert panelists. And thanks for being here.
yeah, so today we are thrilled to welcome an expert panel to discuss the urgent issue of microplastics. Joining us are Christy Tyler, the Rochester Institute of Technology, whose research focuses on aquatic ecosystems, Melissa Duhame, an associate professor at the University of Michigan, specializing in microbial ecology and plastic pollution, and Tim Minotas, legislative and political director at the Sierra Club, who leads advocacy on environmental policy. So together, they'll bring scientific insight, policy expertise, and real world perspective to this critical conversation. So, Melissa, I'm going to pass it off to
Great, thanks. Good afternoon, everybody. I'm Melissa Duhame. I'm going to introduce to you a few really core definitions and concepts that I hope will help you to understand and dive into and receive the rest of the information through the rest of the talk. So, very basically, first addressing this question, what is plastic? And I already want to catch you up on that and restate this question in a way that will make more sense. And that is to recognize that there is no such thing as plastic when we're talking about the plastics and microplastics pollution we find in the environment. And so, really wanting to hone in on this idea that plastics is a plural, there's a plurality to the way that we think about that term. So, what are plastics? In the very definition that we have in the scientific community from the American Chemical Society, we know that they are mixtures. So, not just one thing, but plastics are complex mixtures of one or more organic polymers and additives that are shaped into solid objects. And we use this term plastic or plastics colloquially in the same way and reason why the material type was given its name. And that has to do with the chemical property of plasticity, simply that it is a material that can be shaped and reshaped under specific heat and pressure to give it a form that fits its function. And also want to, we'll get back into this, but plant the seed for those of you that aren't familiar with the concept that most conventional plastics that we use are made from petroleum feedstocks, in other words, oil. And so when you think about what are plastics, what are the different types of plastics, right? We know now it's a plural. Um, we often are brought to these triangle arrows, right? And these seven basic characterizations or labels of different types of plastic. And so, yeah, there are these broad categories, but it's important to remember that these are just still very high levels of organization of what these different types of plastics are. And within each of these categories, they have their own specific physical and chemical properties. But also, each of these components can have different types of plasticizers, alloys and blends, and reinforcing fillers that are additives that aren't themselves plastics materials, functional additives to give it color, form, resist UV, or maybe promote degradation by UV. And even within these big broad categories, there are subcategories of the same chemical molecule at the chemical sense, but that are, because of how the molecules are engineered and how they're put together, can give them different molecular densities. And you see that here with number 2 and number 4. They're both polyethylene, which is the same really molecular structure, but because of how those molecules are put together, you can give the plastic product a different property, either high density polyethylene or low density polyethylene. And all of these things on the right here, those different additives, those are often, that's where the innovation is sparked when it comes to plastics engineering and material sciences. So a lot of these, this combination of 7 times all of these thousands of different creative solutions for giving plastics different properties, that's where different plastic producers and industry, that's where the innovation is sparked. And so there's really motivation to diversify the different forms and functions of plastics at a chemical sense that defines their physical properties. So it's really thousands of possible chemical formulations of what are plastics. There's not one type of plastic. There's not even 7 types of plastics. And each of these have their own properties, including that will influence the degradation and also toxicity in the environment. And so that leaves us with a very challenging problem as environmental scientists and toxicologists, that it's actually impossible to define the overall risks and hazards of plastic or plastics as a category. And so that diversity in chemical form is super important to the rest of what will unfold in this conversation. And it's also makes sense from this background in the chemistry that there's no single legal definition of what is plastic or plastics. Different agencies and even at the state level will sometimes define terms like what is microplastic, what is well, we'll leave it at that. What is microplastics? As they need it, but there's no single legal definition of plastics, which leads to challenges when we start thinking about ways to monitor and regulate. So we'll now come to this life cycle image and diagram, and we'll follow this conceptually through the first 20 minutes of the talk or so. So thinking about plastics, we already talked about how the material extraction that forms what we often talk about as plastic is typically petroleum, oil. So we have some sort of material plastic extraction. But we also have this idea and this term that is in use called a bioplastic. And it's important to recognize that that is not a defined term. Just like there's no legal definition of plastics, there's no legal or even agreed upon definition of how we should use that term bioplastic. In many ways, it's co-opted as a marketing term. And, just the word bio connotes biological, maybe biodegradable. It does give you a sense of maybe this is a better or safer type of plastic, but let's break that down real quick in terms of what it means. So the bio versus the synthetic or conventional plastic, what it's referring to is this first stage of material extraction. And what you should think about is like all living material and biological material, which in its essence, petroleum is. Those are fossil organisms that have been through pressure, time, heat, been compressed into and formed into this fossil fuel. So it was at once a living organism. Where does the carbon of that come from? And if you break down the plastics, you have these polymer chains of many carbons. And for the bioplastic versus synthetic or conventional plastic, those terms you might hear, they differ in where does that carbon come from. So bioplastic means carbon that's recently living things. So that look out your window, you see plants, you see animals. That's the fast carbon cycle. Bioplastic refers to plastics where the carbon has come from that source. And that's in contrast with fossil carbon, where the carbon comes from the petroleum or oil drilled from deep earth reservoirs and used to make plastics. So those are two broad categories of plastics. And we'll come back to why that matters. But remember, there's no regulation on this use of the term bio. Typically refers to where the polymer comes from, not that it's inherently biodegradable or safer. And then microplastics. What are microplastics? Well, that's just referring to the size of the plastic when it's found. And it in itself is really refers to, scientists use it to refer to a category of plastics typically that are less than 5 millimeters in size and down to the nanoscale. And that there is no really the size continuum is fluid. So a water bottle goes into the lake and it starts breaking down, fragmenting into smaller and smaller and smaller and smaller pieces. And really it's a continuum down until it gets back to this molecular form. So microplastics, when you're hearing it in even in this talk, it's referring to the plastics that are in that millimeter to micron scale, and they will look like this if you were to hold them in your hand. But there are plastics that are found in the environment and in human bodies and organism bodies, as we'll learn about later in this talk, that span this whole size range from golf balls down to viruses and even molecules like DNA. And now we'll move into thinking about what happens when this plastic moves on to places that's not intended to be. And Christy will guide us through that.
Okay, great. Thank you. That was a great setup for the next stage. I'm Christy Tyler, and I'm over in Rochester in New York. I help to lead our collaborative for plastics in the environment. And so the part that I'm going to deal with is what happens then this kind of escape from this life cycle that we intend, where end of life then may be recycled back into the system, but we have the escape of plastic from this traditional recycling ideal scenario, and it's going into the environment where it breaks down, and there's a lot that we don't know about what's going on in the environment. And this is my colleague, Matt Hoffman here at RIT, and he's actually sampling an experiment that Melissa will talk about shortly. But he did a first pass of how much plastic enters the Great Lakes. And this was a modeling approach. He's an applied mathematician. And the estimate was that it's about 22 million pounds of plastic every year, which is a lot of plastic. But this estimate doesn't really take into account what kind of plastic, which you've just learned is pretty important, what size, or really where it's coming from, aside from being probably most located in urban centers. Next slide. So we can start to think about estimates of what are the major sources. And MNP in this slide is micro and nanoplastics, which are kind of lumping together as all little teeny particles. And so macroplastic, the big stuff, is actually most of what's coming in, and that's that big blue bar on the right of this diagram. We also get microplastics that are chipping off of paint, plastic pellets that are the pre-production plastic, synthetic textiles, tires, personal care products. And all of those contribute to the microplastic load in the Great Lakes. But in terms of the amount of mass, it's the big stuff that comes in and then starts to break down to become microplastics. Next slide. So understanding what the risk is for the Great Lakes, for people, and for the ecosystem involves understanding that it's not a single pollutant. It's coming from all of these different kinds of places. And then once it's in the environment, it follows a lot of different pathways. And so trying to understand how all of those factors create risk for people and for our environment is an important area of research. Next. So what we've been trying to do broadly is understand how much plastic really is entering the lake and what kind it is. and where it comes from, with the idea that most of the plastic, both macro and micro, is coming from the land and moving through rivers and streams out to the lakes. But those aren't just pipes. The plastic is getting hung up or interacting with the environment. We know that stormwater, particularly urban stormwater, is a major pathway. This is a storm drain in Rochester, and you can see the different kinds of plastic that are on top of the drain. And most of the plastic, up to about 98% of the plastic that's going in the lake into the oceans and probably into our lakes, is big when it starts. So next slide. So one of the things we've been trying to do is figure out how much this is and what is it. So we've been using these debris interception devices in Rochester to capture plastic entering storm drains, and then we go through a whole process of categorizing it, measuring it, weighing it, checking out what kind of plastic polymer it is. Next slide. And this is just a snapshot of some results. And I just want to highlight a couple of key points with this. And one is just, you can see the variation in the size of the bars. And some of these sites are within a block or two of one another in the city of Rochester. So the amount of plastic that comes in and then the composition of that plastic that comes in and the debris in general is really, really variable. So coming up with solutions has to be a very local route. We have lots of rocks and cement that come in, but after all of those that are very heavy, plastic is the most common material. And most of this is packaging and various single-use products, mostly associated with food. But we also see a lot of cigarette butts, which are one of these kind of semi-synthetic polymers. It's cellulose acetate. So it's considered a type of plastic. So cellulose acetate, polypropylene, and polyethylene are the three plastics that are the most common. These are also then have all kinds of other chemicals that Melissa mentioned in them. So understanding the material and the source, which we can get by looking at what kind of product it is, helps us predict what kind of mitigation and risk. And one thing I wanted to point out with this is that each of these is one drain over a 2-year period. And in Rochester, we have 30,000 storm drains. So you can multiply this up and we get that it's more than 7,000 kilograms of plastic that are entering Lake Ontario just from the city every year. Next slide. So one of the other things we're doing is also measuring microplastic in the nearshore region to figure out if these products are breaking down and persisting. And we see a lot of PE, which is the polyethylene. It's buoyant, so it's going to travel. We also see PET, which is a less buoyant polymer. In the water column offshore, we don't see cellulose acetate. And this is likely because it's very dense, and as soon as it gets into the water, it sinks down to the bottom. And so these characteristics of the individual kinds of plastics are really important in understanding where it's going to go in the ecosystem and then the ultimate fate. And I'm going to turn it back to Melissa to talk about fate.
There we go. Yeah, so what happens once the plastic reaches the environment? That's also among the questions that we ask in our lab. So where does the plastic go? What and who does it impact? And another area that we focus on that I won't present as much in the slides, but happy to talk about more in the Q&A afterwards, is what about the biodegradation of plastics by environmental microbes? We know there are 1 million microbes in every drop of water, and as soon as the plastic enters the water, the colonization by those microbes begin. So we know to answer the question of where does it go, it's important to follow the water to be able to follow the microplastics. So as Christy pointed out, some of the pathways that we know of originating from land, moving in through water. But once in the water, where do they go? And that's among the questions that a large binational collaborative team led by Chelsea Rockman at University of Toronto has been seeking to answer the question of through like whole ecosystem lake manipulation. So truly seeking to understand the fate and the effects of microplastics in aquatic ecosystems, given that the fate of most environmental plastics will be water quite quickly. So this is an aerial view of some of the early experiments we did. They're called mesocosm experiments, where essentially they're big soft-sided enclosures in a whole lake system that are anchored to the bottom. And that then gives us environmental conditions through a season that we don't have to worry about recreating in the lab, but we can contain the experiment and do replication and control the types and amounts of plastics that we put in, and we can still monitor ecosystem effects and food web effects. We know there are phytoplankton in these enclosures. We can put fish in them and other organisms. So the purpose of this experiment was to determine the impacts of the concentration as well as the chemical formula and different additives of plastics that we had synthesized with certain formula. So here you can see this is one of the types of plastics, one of the floating types of plastics. And so we replicated this over many seasons. So a few of the papers have come out now. You can look for them by the name Rockman, ES&T. There's one this year, one last year of the first round of experiments. And one of the most striking things that I wanted to share with you today is that what we found, because we know when the plastics are added, we can then see how long it takes for them to move through different, what we call ecosystem compartments in the lake. And what we learned was that in a matter of days, most of the plastics are gone from the surface of the water column. And that was really important and profound for us to learn, because a lot of the first decades of work gathering data on microplastics in open water bodies were going along the surface and skimming the surface and getting counts and numbers and concentrations around the Great Lakes and rivers and oceans. But what we saw was that within days, most of the plastic was gone, either down at the bottom or on the sides. And so either the plastic's moving to the sediment or are beached. And so this is important findings when it comes to monitoring programs like state implemented monitoring programs, as well as mitigation and kind of the plastics forensics, trying to figure out where it comes from and what the sources are. We have to get better estimates of where the plastics are going. So this is more images from that whole lake system looking at the plastics. So in the following year, we actually added microplastics to this experimental lake. And for 3 years, we added it and tracked these types of metrics. And now we're tracking it through the entire food web and where it's going if and when it does leave the lake. And that allows us to now follow this whole ecosystem for many years. Up until 2030, we hope to maintain this project, looking at mitigation and long-term monitoring, measuring the fate of the plastics over these long periods, as well as developing and testing cleanup methods. And we have already begun publishing standardized methods and risk assessment reports that are informing policy relevant to microplastics mitigation, both in Canada and the US. So it's been a very productive and important experiment. I want to go back to the seed that I planted earlier in terms of what is a bioplastic versus a conventional plastic. All these different polymer types, and what we know in terms of how it behaves in the environment is that the polymer type matters. All those different thousands of additives, they matter in terms of things like the physical properties, the biodegradability, as well as the persistence. Like, how long will this plastic last in the environment? Is it compostable? What are the risks to humans and wildlife? The types of additives that are there, whether a plastic is deemed reusable or upcyclable, how durable it is, the shedding rates of the plastic item, whether it can be repaired. All of that is the answers to those questions, or variation among those traits, all depends on the type of polymer and additives that are there. So those thousands of types of plastics really have implications. And when we're picking up little bits and pieces of plastics in the environment, it's nearly impossible for us to know, because those chemical formulas are proprietary, when we do our analytical techniques like spectroscopy that can give us the chemical signatures of what comprises that polymer, we cannot tell all of those additives. And so that leaves us in a challenging situation when we're trying to, on the back end, try to figure out what is there in the environment and what is really there in a chemical sense and what the risks might be. So on the right here is an image that I wanted to show. So after about 200 days in the environment, there's 5 different plastic types. Here's our conventional oil-based plastic. Here's a blend of like bio plus oil-based. Here's a purely bio-based, PLA it's called. And then here's some other cellulosic material, cotton and lyocell. And what I wanted to show is that this bioplastic, it persists just as well as the oil-based conventional plastic. So keep this image in mind in terms of just because it's bio-based doesn't mean it's more biodegradable. It is just as persistent and can be just as persistent in the environment. All right, now we'll move into the last round of this interest.
Okay, thank you. So I'm only going to talk really briefly about this, but I think one of the most concerning things these days are all of the headlines we're seeing on plastic in our bodies and what the potential impact on human health is. So next slide. A lot of the work that's being done on plastic pollution is being done within this umbrella of One Health, which is the idea that human health is kind of inextricably linked with environmental health and animal health, and that what we're doing in the environment is coming back through ecosystem health, but also influencing human health. So that's the umbrella for this. Then I wanted to come to some of what we're seeing in the news. So this is a paper that was also from Chelsea Rockman's group at Toronto. Eden is one of her PhD students, and they did kind of an assessment towards understanding ecological risk, setting up a framework for this in the Great Lakes. And what came out of this paper was a headline that said 90% of Great Lakes water samples have unsafe microplastic. And this was scary. I saw even kids that we were working with through outreach pick this up and put it on flyers and that kind of thing. Next slide. But what they really said in the paper was that in about 90% of the surface water samples in the Great Lakes, there's enough microplastics that it might pose a risk of food dilution toxicity, which means that for something like a zooplankton that's a filter feeder of phytoplankton, there might be enough plastic in it that it starts to influence their ability to get enough food because the plastic is mixed in there with the phytoplankton. So we see these kinds of kind of the way the spin in the media is makes it really, really scary. And so trying to understand the real risk and whether or not we've exceeded thresholds is something we're really just beginning to do. Next slide. So some of what we do know is microplastic is in our body. It's in our hair, it's in our saliva, it's in breast milk, it's in your gut, it's in our brains, it's in your reproductive organs. So we know it's in our bodies. We're kind of bathing in a microplastic soup all the time. Next slide. But it's really, really hard to know what the effects of this are. We don't do microplastics related experiments on people, so a lot of it is correlational. And they're extremely hard to measure, especially when they're really, really small. So plastic that's less than 1 micron, you can't measure with traditional microscopy. And so there's a lot of techniques that are not perfect. And some of it is that there's so much variability in the plastics, and that variability impacts its toxicity. So the size and shape, whether it's really tiny and can cross cell walls, the surface characteristics, if it's degraded, the chemical properties of it, does it have polymers or added the polymer, the additives, what chemicals it's attracted from the environment, the type of microbes, often pathogens or antibiotic resistant bacteria are on the surfaces. It's also trying to separate the effect of a particle versus the effect of the chemicals that come with the particle. And we know that a lot of the chemicals that are in plastic have known health effects, things like BPA and PFAS. Some of the dyes, plasticizers, we know that those are bad for us. There's also a lot of variability in our exposure. Does it come in through your skin? Are you breathing it? Are you ingesting it? And all of those different routes of exposure influence the toxicity. Next slide. Some of what we do know from laboratory-based studies and animal studies are things like that it causes cell damage, it impairs metabolism, it may have issues associated with cardiovascular dysfunction or behavioral alterations, changes metabolic efficiency, it may change your resistance to diseases and other kinds of pathogens. So there's a growing body of evidence that it's not good for you. Next slide. But one of the things that's really needed and something we're trying to do in Rochester is that the environmental scientists need to talk to the health scientists because we're understanding where it is in the environment, what's coming in, what is it, what kind of products, what's the exposure, and the health scientists are doing analyses in the lab. So the Lake Ontario Center for Microplastics and Human Health, which is funded by both National Science Foundation and the National Institutes of Health, the goal of that is to put environmental people in the same room with health researchers in order to try to get at some of these issues. And so I just wanted to end. I usually start my seminars with that slide. You can go to the next one, this one. That plastic is a really useful thing. I dumped out my purse once when I was going to give a seminar, and this is all the stuff that's in it, and it's all plastic. And it's things we use all the time, my glasses, my chapstick, my keys, my ID. And so taking a balanced approach that's informed and figuring out which polymers cause the greatest risk and then how do we tackle those is a really important piece. And so I think that kind of leads into the next section with Tim talking about some of the policy that goes with that.
To get this up, hold on 1 second. All right, can you all see my screen? I'm screen sharing. Okay, cool.
Yes.
Perfect. Well, hi everybody. Let me see if I can get my camera rolling again. Well, it's not popping up. Well, hi everybody. My name is Tim Minotis. I'm the legislative and political director for the Sierra Club, specifically in Michigan. I focus around state policy and really all things environmental policy, but one big policy area that I do focus on because of the growing interest in a bipartisan fashion is microplastics. And so I'm going to be talking a little bit about, microplastics, at the state level and in terms of state policy. And so I'm going to be giving a brief overview and lay of the land of where we are at, some of the most popular policies we are seeing at the state level, and in particular, Great Lakes states, go into some key challenges and emerging trends as we move forward and takeaways that, we are seeing out of state policy, here in 2025. And so to kind of just level set, at the national level, the Microbeads Free Waters Act that was passed in 2015 that put a ban on microbeads in rinse off cosmetic products, and so that remains the only enforceable federal ban. And while there's the EPA's national strategy to prevent plastic pollution that outlines goals, but it does not set any binding standards. And there are other pieces of legislation introduced in Congress right now to deal with microplastics in various different ways. But as of right now, from a federal level, The only kind of enforceable ban and action we have is that Microbeads Free Waters Act from 2015. So across the U.S., states microplastic policies, they're expanding beyond the original microbead ban to cover a wider range of pollution sources. Legislatures are advancing measures that target microfibers from laundry, requiring monitoring of microplastics in drinking water, looking at further microbead bans in different products and consumer products, cleaning products. And also at the same time, many states are looking at broader plastic laws such as bag bans, foam foodware bans, extended producer responsibility. These are policies looking at reducing the upstream generation of plastics that ultimately fragment, into these microplastics, nanoplastics. So together, these policies really reflect the growing recognition that microplastics are both a pollution and public health issue, and states are really starting to step into that regulatory gap and driving innovation while the federal standards remain limited. And so, one of the issues, though, with various different states taking policies. While some may be similar, state policies and actions are very widely. There is no consistent definitions, standards, or enforcement mechanisms, leaving kind of a patchwork approach to addressing the microplastic pollution. So, like I mentioned, I'm going to be focusing on 6 policies that we are seeing across the country and in our Great Lakes states. And we have over actually 17 states that have enacted policies right now, and over 10 states here in 2025 looking at policies in front of their state legislatures right now. So the first one that we are seeing, and actually something my home state, Michigan, is trying to do, and just introduced a package around, is that we are starting to see states introduce legislation as well as through regulatory means through state agencies taking action around drinking water monitoring and creating statewide strategy plan. And so, the reason why, states from both a regulatory agency perspective as well as legislative perspective are looking at these policies is because right now states don't have a complete picture of where microplastics are coming from, how much is out there, the full risk to people and wildlife, and putting monitoring plan and strategy plans together, it allows the states to assess microplastics in the environment, the Great Lakes ecosystem, in our drinking water, to evaluate that ecological, human health, and economic impacts. And so you can't manage what you can't measure. And states are currently lacking a coordinated statewide approach. And so the data from these policies and strategy plans and monitoring plans will help identify those priority sources, high risk areas, and will help drive effective, intervention. And so this allows them to build that baseline line data to inform that regulation and treatment strategies and to formulate those scientific baselines that help formulate the best recommendation of policies states can take. And so right now, Michigan has legislation pending right now. There's actually a committee hearing the other week on similar bills around drinking water monitoring and creating a statewide strategy plan. Illinois has something similar. Minnesota has legislation in front of them right now. While not as expanding, it does study microplastic. There's a piece of legislation around studying microplastics in meat and poultry. And then, of course, other states have actually implemented this. California really being the leader here, and then New Jersey and Rhode Island as well as looking at state policies here. Next is microfiber filters. And so these are policies requiring microfiber filters on washing machines. And these are important for addressing microplastics because household laundry is actually one of the largest sources of these pollutants in the environment. From what we can gather, that a single load of laundry can release hundreds of thousands to millions of fibers into wastewater. And these fibers are too small for most wastewater treatment plants to capture. So they end up in our rivers, lakes, oceans, streams, you name it. So filters are really part of one piece of a larger strategy uh, here right now. And so why, so states are looking at implementing and pushing policies that would require filters on new washing machines. I will say no state has enacted such a law yet. There's only pending legislation. And so we've seen this in Illinois right now, New York, Pennsylvania, in our Great Lakes states. And again, these filters on washing machines are a source control solution. So it's really to stop pollution before it enters the watershed. And this is generally more effective and less costly than trying to remove microplastics, downstream. And so, and it provides and ensures inconsistent adoption rather than relying on voluntary consumer action. And by setting standards and requirements, such policies like this can help drive innovation, create economies of scale for filter technology, normalize microfiber capture as a baseline expectation. And so, again, we're seeing states starting to introduce such legislation, but no state has actually enacted into law yet. Microplastic controls. So this is dealing with microbeads. This is a policy, as you remember, I mentioned the federal law that already prohibits rinse off microbeads across the country. What we are seeing in other states do right now is to expand. Um, so we're seeing states, expanding upon the federal law to include things like cleaning products that use microbeads. Industrial household cleaning products are a point of microplastic pollution. So we're starting to see states expand upon it. And so to create their own state policies, because the federal law doesn't cover leave-on products like lotions and makeup. As I mentioned, doesn't include industrial household cleaning products. Um, Federal policy doesn't address biodegradable or alternative polymers that might still pose microplastic risks. And so states have expanded upon this in their own way, and each state is different. And so, Michigan, we also have some pending legislation right now that would put a prohibition on cleaning products, industrial and household cleaning products. Illinois as well. And then of course, once the federal law took effect, it created a national baseline for that rinse off cosmetics across the country. And really, what led to that is that many states prior to 2015 were starting to look at the cosmetic products and started to implement policy and bans in their own states, which ultimately led to this national legislation. Extended producer responsibility is something we are seeing across not only the United States, but also globally, especially in Europe. And so this is a policy approach that makes producers, responsible for their products along the entire life cycle, including at the post-consumer stage. This is a designed environmental policy approach that shifts the burden of managing certain end-of-life products from municipalities and taxpayers to the producers who place those products in the market in the first place. And so this shift really relieves local governments of growing waste management costs, especially as waste volumes increase. And of course, um, the goal here is to really reduce packaging waste, increase recycling rates, and to promote, use of more sustainable materials. And so, really, extended producer responsibility laws, encourage the design of products that are, easier to recycle, made with less toxic or virgin material, more circular by design, and they're, are used to gain traction because they are also addressing the rising costs of environmental impacts of waste as well as the costs of waste. And so these are seen as a fair, effective, and future-oriented way by states to make producers part of the solution instead of leaving the burden on communities. And so Minnesota's actually enacted a law around extended producer responsibility. Michigan, we had legislation introduced last session, and I know New York and Illinois had legislation before them as well. And then 7 states already across the country have enacted such EPR legislation, and there are several more that are looking at bills that are at various stages in their states. Plastic bag bans, fees, restrictions. This is probably something you all, have seen and heard a lot about is that, this is exactly what it is. They are policies designed to curb, single-use plastic bag use by either, prohibiting them outright, or some states, requiring retailers to charge customers a small fee, or limiting their availability through various different hybrid approaches. And there are some exceptions to the laws. And so these measures are obviously aimed to reduce waste, encourage reusable alternatives, cut down on plastic pollution, as well as giving municipalities the ability to enact their own regulations and ordinances. For example, in a state like mine, in Michigan, we actually have a local preemption law here that was passed in 2016, stating that a local unit of government could not create an ordinance around plastic bags or plastic products. We have a piece of legislation to repeal that law. And so some states are looking to repeal such similar laws like Michigan. New York enacted an outright statewide ban, and other states are looking at that right now, like Illinois and Pennsylvania. And then various other um, states across the country are looking at such state laws, and then hundreds of cities across the country have created their own local ordinances around this. And the reason why is that, these are seen as simple, visible policies that deliver quick, measurable results, dramatically reducing bag use while encouraging more sustainable alternatives. And then there's polystyrene, foodware bans, very similar to the last slide. This is really looking at restaurants, schools, food vendors from distributing foam containers. Others go further by banning retail sale, foam coolers, and like packing peanuts. And then, the reason why is because these materials are nearly impossible to recycle. They break down into microplastics. They're also costly to cities again for cleanup, landfill space, helps protect public health, reduce waste, and cleanup costs. New York has enacted a law. Illinois has, and there's also various dozens of states looking at similar state laws. There's some like uniqueness too in this because there's also states that also just look at like encouraging um, uh, like some states are pushing policies where it allows customers to bring in their own containers that they can use for takeout. Some states are also looking at ensuring greater access to like reusable um, uh, water stations. And so there's some various different ways states can get creative outside of just outright bans. And so some key challenges that we are looking at and is that, with a lot of these policies and only having the one standard at the federal level, that there's a lack of standards, there's inconsistency, a lack of shared definitions and enforcement capacity. There is we are still facing data gaps about the health impacts of microplastic exposure. And there's obviously ongoing work around this, as we just heard from the two presenters before us. With that scientific research, states are looking to and are working to design their own definitions, testing methods, and timelines, creating some inconsistent regulation. And so there's also limited monitoring and enforcement capacity while states are going through budget issues. Some states have dedicated funding and infrastructure for this, but a lot of states do not. And of course, there's industry resistance to this. Most of the emergent trends that we are seeing is that states are starting to link plastic policies and microplastic policies with other toxic chemicals, especially around PFAS. We are also seeing interest in targeting big sources like textiles, tires, pellets in their policy framework. And then we are also starting to see states look at drinking water monitoring and putting together pilots through that. And then there's some regulatory aspects too. For example, um, through like settlements. For example, the state of Pennsylvania, through a Clean Water Act settlement, was able to get zero pellet discharge provisions after alleged releases. And so there's some other regulatory legal action that is going on that has helped driving some of this, as well as other state procurement policies that the executive offices and states are implementing. And so the bottom line is that states are driving U.S. microplastics policy, and the action is shifting, every day, every year. The big constraints are, no federal baseline, as well as, we're still figuring out what the best methods and definitions are, and really gathering the information about what the health impacts are. So, over the next year or two, 5 years, we certainly expect more policies around not just the six that I just mentioned, but also working towards a growing alignment and regional coordination among states and Canada, really laying that groundwork for further cooperation. And these issues are also transcending party lines and getting bipartisan support too. So this isn't just a Democratic issue, Republican issue. We see members from both sides of the aisle taking interest in this. And so I will stop right there.
Great. Thank you guys so much. Yeah, I feel like I learned so many new things. So thank you to all of our speakers and experts. If I haven't met all of you guys on Zoom, I'm one of the grad students helping the GLBN with this microplastics work. And so we're just going to take, we just have a few minutes, but we'll try to take a few questions for any of our speakers. So feel free you can come off mute, or if you want to put something in the chat. It could be directed at one specific speaker, or it could be for kind of the group at large. So feel free to let us know any questions that you have.
I got one.
Great. Thanks, Sam.
Hi, Sam Bennett, work as an independent consultant, working with businesses and nonprofits to just drive partnerships, and then also work at Tent Craft, where we make pop-up tents here in Michigan. If we've got one action we could take, should we be advocating for policies or looking at our supply chain and seeing if we can source better materials? It's probably a yes and, of course, but just curious your guys' perspective. Talking Michigan specific if we want to get, and maybe it's
I,
GLBN specific.
to your point, I would say yeah, it's an and. I think from both different ways, like companies taking like action on their own helps drive that market within itself. I mean, state policies can do that, but when companies, take the initiative themselves, the innovative approaches, looking at their supply chains, that helps drive the market and the interest itself to start direct by companies demanding like cleaner supply chains and more sustainable products helps shift the market away from these single-use plastics. And obviously, state policy can do that through various different, whether that's an incentive, extended producer responsibility policy, even bans that control the pollution at the source from a manufacturer standpoint. So I would say it's both. Yeah. So
I can give maybe a little bit of historical perspective too. When I heard your question, um I thought of this image, and I'm gonna take the liberty of sharing my screen one more time. Um, so this is 1950s Life magazine. What you see is just like these objects being thrown into the air, like, and literally the line in this picture, cleaning up these objects would take about 40 hours, except no housewife need bother. So that was in the 1950s. And I'm reminded of this, the first paragraph of this book is called Pollution is Colonialism. It's written by Max Liveron. And they start off by saying in the 50s, Lloyd Stauffer, the editor of US magazine Modern Packaging, I just grabbed the book, so I'm reading it right now because it's the very first paragraph. He made this statement to the Society of Plastics Industry meeting in New York City. And he says, "The future of plastics is in the trash can. It is time for the plastics industry to stop thinking about reuse packages and to concentrate on single use." And essentially, for the package that is once used once and thrown away, like a tin can or a paper carton, it represents not a one-shot market for a few thousand units, but an everyday recurring market measured by the billions of units. So that was like 75 years ago. And so recognizing that, like, the current situation where, at that moment, the consumer markets were saturating, the plastics industry needed a strategy to, boom in that moment. And disposability was a tactic. It was a tactic of that industry. And that is, I think, when markets are rooted in, capitalistic systems like ours is, that will be an inevitable outcome unless there's other pressures. So when I think of things like this Life magazine image, there's a cultural component. So thinking about what are the different facets of, like, tackling this from a cultural perspective. What is deemed normal? Bringing your own, containers for takeout. Sure, we can shift to that. So that is something on the consumer side, culture shift. But I think we absolutely need these policies that Tim was presenting about. I think of like the EPR. I think 1991 is when the first EPR law was implemented in Europe. Like, how many millions of tons of microplastics has the US released into the environment since the 90s? We are so slow in implementing these policies, as well as those that might kind of create different types of market pressure for industries that are kind of not right now constrained by those limits. So to echo Tim's voice with that cultural perspective, just want to say, yeah, all of them now.
Yeah, that was super interesting. Thanks so much. I understand if people need to hop off. We do have just a quick survey form that we put in the chat that we would really appreciate you to fill out. But if anybody would like to stay on for a little bit longer, we could probably take at least one more question for our experts if anybody has one.
Hi, it's Juliet. I don't really have a question, but I just think the conversation's been really, really interesting, and I enjoyed the presentation a lot. It made me think, just about how much the food industry is playing in this, and when you said the large percentage of the is coming from food packaging. I'm a farmer, and I have just in my lifetime seen the change into plastics. And it's driven by food safety, and it's driven by globalization and the consolidation of our food systems. So, when I was a kid, we would still pick cherries into wooden lugs, and now they're picked into like plastic lugs, which is like a 20-pound container. Um, and and that's just in the like bulk sense, but like everything, you know, it just I don't really have a question. I'm just kind of spitballing and observing here of like that we have come, the driver in this has been food safety and cleanability and uh but we've gone down such a path that like I don't know how you come back from it. So a few years ago, I'm the handle the food safety audits here on my farm, and we sell apples to a distributor that gets sold into Walmarts and Aldi and everything. And a couple years ago, the distributor said we really want all of our growers to be using plastic bins to put apples in because it's better food safety. Um, and I pushed back and I just was like, no, I, I'll lose a couple points on my audit. So we still use wooden bins for our apples, but uh, it's just when you think about the food industry, I don't know how we like slow and turn it around when we're talking about this global industry and everything. But anyways, sorry for my rant. It was a great conversation today, so thank you.
I could just tag onto that a lot of times when we're asked about how you avoid microplastic exposure, that it almost feels like a luxury to be able to recommend these options. Going and buying your food, organic, not wrapped in plastic, it's more expensive. Or using a silicone bag for your sandwich that costs, I don't know, $10. As opposed to a little box of Ziploc bags. And it starts to bleed into being an equity issue where in our research where we find the most trash is in food deserts, where everything is sold at the corner convenience store in little tiny packages because that's what's affordable. And so you're right about it being embedded in the whole food system, and that it needs to start back at the beginning of that chain, and different mechanisms and systems for food safety and food distribution that don't involve plastic, and toxic chemicals embedded in our plastics that's on our foods. So I agree with you.
Any final questions from the group before we do one last plug for the survey? In that case, I just want to thank all of you that are here today and that took the time to join. It means a lot that some of the people that we've interviewed and talked to were able to join today. And we know you guys have busy schedules, so it means a lot to us. So if you wouldn't mind taking the time before you leave, going to that link in the chat to our survey, which we're going to use for informing our next webinar if we have one, and for our research, that would be great. And you can always reach out to us with more questions. We can direct them to the experts that we've had here today. So yeah, please fill that out, and I hope you guys all have a wonderful day.
Thank you guys so much.
Thank you.
Mhm.